All right, so we're going to look at rational functions. So we've got our slightly creepy mascot here, but yeah, he might need a makeover some stage because he's looking a bit weird. But anyway, we're going to look at rational functions, and so a rational function is a rule that has a form of like this. So f of x equals p of x divided by q of x, where p of x and q of x are polynomials. So polynomials, remembering x to the power of n is the highest term, and then x to the power of n minus 1 is the next highest term, and so on, and it's got real number coefficients. So if we look at an example, you could have something like this. Clearly in the numerator we have a polynomial, and in the denominator we have a polynomial. But sometimes we just have to be aware that it won't necessarily explicitly look like a rational function, but something like this is also a rational function. So let me explain. So g of x equals 2 plus 3 on x might not look like a rational function at first glance, but if you just write that 2 as 2x over x and then you add 3 on x, you'll get 2x plus 3 on x, which is clearly a rational function because you've got a polynomial divided by another polynomial. So what we'll do is we'll investigate another example of a rational function that might not look like a rational function to begin with. And here it is. So if we've got this, h of x equals x plus 4 on x squared plus 1, if you rearrange this a little bit by the same logic as before, you'll get something like this. Again, that x, you just write it with a common denominator of x squared plus 1, and you'll get this x cubed plus x plus 4. And then what we might want to do is we want to sketch that. Okay, so what we could do is sort of set up our axes. We'll get something like this, and when we're sketching it, looks pretty cool. When we're sketching it, we can see that that first term x is actually easier if we leave that there, because we can actually see that we've got what's called, or we've got an asymptote here that isn't a vertical or horizontal asymptote. It's actually an asymptote that's equal to the line y equals x. And the reason we get an asymptote at y equals x is because if you imagine, if we had a really large x value, in the denominator of that second term there, you'd get 4 over something really large, which essentially goes to 0. And then that really large number would be placed in that first term, x. So as x gets really large, the value that this function approaches is whatever that value is of x, because that second term goes to 0 because it's got x squared in the denominator. So what we'll do in a later video is we'll fully explain how to sketch these functions. But yeah, hopefully you can see where that sort of asymptote comes from. I encourage you to sort of think about how you could graph this without obviously me showing you. And yeah, if you want to think about x and y intercepts, you also probably want to think about stationary points. And then you can really start to put a clear picture together about what the function looks like. And even taking the derivative maybe might be able to tell you some key information, and maybe the second derivative. So I'll put some links below to cover that, but we will do a lecture on rational functions, so that's coming up, but I thought this is a nice introduction. As always, if you found that useful, give us a thumbs up, let us know how you're going. If you need any private tutoring, I'll put my email in the link below, and good luck with everything you're doing, and I'll talk to you soon.